Hello, engineers, Venikam, and a huge welcome to all of you, my future TNPSC AE, SSC JE, RRBJE, and GATE toppers. Seriously, if you're ready to build a rock-solid foundation for your engineering career, then you are in exactly the right place. Let's jump right in.
Welcome to The Explainer. Our whole mission here is to take these really complex subjects and just break them down into simple, easy-to-understand concepts. And today, our entire focus is on mastering the fundamental properties of soil. In the concepts punjitinali, if you understand these concepts, you've honestly won half the battle for your exams. So let's build that winning foundation together.
So here's our roadmap for today. First, we're going to start with the absolute basics. What is soil mechanics? Then we'll dive into the single most important concept, the three-phase system. From there, we'll decode void ratio, porosity, see how they're related, and finally, wrap up with a degree of saturation. We're going to master each one step by step.
Okay, first things first. What even is soil mechanics? Well, think of it as the absolute heart of geotechnical engineering. If you're a civil engineer, every single structure you build, whether it's a building, a bridge, a massive dam, it all rests on soil. Understanding how that soil behaves, that's everything. In this subject on, unga structures ka basement. This is the basement for all your structures.
So, soil na, what is soil? The textbook definition might sound a little complicated, but it's actually really simple. Soil is basically just a collection of tiny mineral particles. Mannanu solromla, adan. That's what it is. The key idea here is that these particles aren't strongly cemented together. If you were to take a handful of soil, put it in water, and just shake it, the particles would separate. That's all gentle mechanical means is referring to. And this is the primary material we are going to be studying.
All right, I need you to pay close attention here. This is, without a doubt, the single most important, fundamental concept in all of soil mechanics. I promise you, if you can understand the diagram we're about to break down, you can solve probably 50% of the problems in this entire chapter. It is that crucial. The biggest mistake people make is thinking of soil as just one thing. It's not. Soil is a mixture. It's a system. And more specifically, it's a three-phase system. I'm going to repeat that because it's so important. A three-phase system. So what are these three phases? Well, first, you've got the actual solid particles, the mantagogol. Second, you've got water, which can fill up the little empty spaces between those particles. And third, you have air, which also occupies those same empty spaces. Solids, water, and air. Simple, right? Exam alert, this phase diagram right here is an absolute must-know for 2-mark questions. Let's break it down. We represent the total volume of the soil, V, with this whole block. The bottom part is the volume of solids. We call it VS. Now, the spaces between these solids are called voids, and these voids can be filled with water, that's VW, and air, that's VA. So the total volume of voids, VV, is just the volume of water plus the volume of air. Makes sense, right? And the total volume, V, is simply the volume of solids plus the volume of voids. Purinjda, understood? V equals VS plus VV. Romba mukyam, very important. Okay, now that we have our phase diagram all set, we can start defining some key properties. And the very first one is something called the void ratio. It's basically a way to measure just how much empty space is inside the soil. The definition is pretty much right there in the name. Void ratio, which we symbolize with a lowercase e, is simply the ratio of the volume of voids to the volume of solids. The formula is right there, E equals VV divided by VS. Now, this is so critical because it tells us how dense or how loose the soil is, and that directly impacts its strength and how much it's going to compress under a load. Okay, here's a classic question that you'll see in exams, and interviewers love to ask it. Just think about it for a second. Can the void ratio, E, actually be greater than 1? Is it possible for the empty space to be more than the solid space? The answer is yes, absolutely. For some very fine-grained soils or soils that are really loosely packed, it is totally possible for the volume of the empty spaces, the VV, to be larger than the volume of the solid particles themselves, the VS. So yes, E can definitely be greater than 1. In fact, there is no theoretical upper limit for the void ratio. You have to remember this key point. All right, next up, we've got another term that also measures the emptiness in the soil. It's called porosity. Now, it's related to void ratio, but there is a very, very important difference. Let's take a look at what it is. So porosity, which we symbolize with an N, is the ratio of the volume of voids to the total volume of the soil. Now please, pay close attention to the difference. For void ratio, our denominator was the volume of solids, Vs. But for porosity, it's the total volume, V. So the formula is N equals VV divided by V. This distinction is absolutely key.
So the crucial point is, just look at this comparison. This is a common trap in exams. Void ratio compares voids to just the solids, but porosity compares voids to the total volume. Now think about it. Since the volume of voids, VV, is always just a part of the total volume V, porosity N can never be greater than 1. It will always be a value between 0 and 1, or if you're talking percentages, 0 and 100%. This is a mukyamane difference. This is a very, very important difference.
Okay, so now let's connect these two ideas. In exams, it's super common for them to give you E and ask for N, or give you N and ask for E. This means you absolutely must know the relationship between them. Luckily, there's a very simple formula that connects them both. Let's just arrive at real quick so you see where it comes from. We start with the definition, N equals VV over V. We already know that V is just Vs plus VV, so we can substitute that in. Now here's the clever part. We divide both the top and the bottom by Vs. So what's VV divided by Vs? That's E. And what's Vs divided by Vs? That's just 1. So we get our final golden formula, N equals E divided by 1 plus E. Please, I mean it, write this down and memorize it. Okay, let's test this out with a quick example. Let's say the porosity N is 33.3%, or 0.333. And just to be super clear, this is an assumed value we're using only for this example. So if N is 0.333, what would the corresponding void ratio E be? Take a second and try to calculate it. Well, if you rearrange that formula we just learned, you get another very useful version. E equals N divided by 1 minus N. So you just plug in 0.333 for N. That gives you 0.333 divided by 1 minus 0.333. And that gives us our calculated result, 0.5. See? It's really simple once you know the formula. Fantastic. We are on to our final property for this explainer. So we know there are voids in the soil, right? But are those voids filled with air, or are they filled with water? The degree of saturation tells us exactly that. It's all about the water content within the voids. So the degree of saturation, which we call S, tells us what percentage of the total void space is filled up with water. The formula is just the volume of water, VW, divided by the total volume of voids, VV. And then we multiply by 100 to get a nice percentage. It literally tells us how full of water the empty spaces are. And this leads us to 3 possible states for the soil. First, if there's no water at all in the voids, meaning VW is 0, then the soil is completely dry and S is 0%. On the other hand, if the voids are completely filled with water, so VW equals VV, then the soil is fully saturated and S is 100%. And anything in between, where you've got both air and water in the voids, we call that partially saturated. These 3 terms are so important. I want you to remember this. Mastering these fundamental properties, void ratio, porosity, saturation, it's not just about passing an exam. It's about really understanding the very ground beneath our feet. You're literally learning how to build the future, one stable foundation at a time. And that's all for part 1. I really hope everything is crystal clear. In part 2, we are going to tackle the different types of soil densities, another super important topic. So make sure you smash that subscribe button and ring the bell icon so you don't miss it. Your dream job as an engineer is waiting for you. Let's go get it. Thank you.